Hello Year 3 and welcome to this maths video, which is for the rapid reasoning session on Monday the 1st of March. So here is your problem for today. I'm going to read it to you and then I'd like you to have a go by yourself. If you are really struggling with it, then watch each step of the video because I give you little hints and ideas before finally telling you the answer. So it's called Biscuit Decorations and it says, Andrew decorated 20 biscuits to take to a party. He lined them up and put icing on every second biscuit. Then he put a cherry on every third biscuit. Then he put a chocolate button on every fourth biscuit. So there was nothing on the first biscuit. How many other biscuits had no decoration? And did any of the biscuits get all three decorations? So think about how you might solve that and how you may answer both of those questions. A little hint is think about how you could represent it. Maybe you could draw it. But have a think, have a go, and then keep watching if you're struggling, and I will go through some little hints. So, hint number 1. This is how I did it. I represented each of my biscuits. So each square represents one biscuit, and I've numbered my biscuits 1 to 20 because I thought that might make my life a little bit easier. I've got my instructions up here that he lined them up and put icing on every second biscuit, a cherry on every third biscuit, and a chocolate button on every fourth biscuit. And I've colour-coded those words. Think about how you could use my grid and my colour coding to see if you could answer the questions. So, hopefully you've had a go. Now what you need to notice here is that there's icing on every second biscuit. So what that means is no icing on 1, 2, yes icing, 1, 2, yes icing, 1, 2, yes icing, 1, 2, yes icing, and so on. And hopefully you noticed that you're putting icing on every even number because it is every second biscuit. So I can count up 1, 2, yes, 1, 2, yes, 1, 2, yes. Every second biscuit has icing, and I could write icing in that box. Now that I've told you about the second biscuit and that you would count 1, 2 and put icing in every second box, how does that help you with the fact you put a cherry in every third biscuit? Have a think. So hopefully you were able to go through and put cherries, the word cherry or draw a cherry, in every third biscuit. So 1, 2, 3, yes. 1, 2, 3, yes. What do you notice about every box that has a cherry in it? So hopefully, once you've put all your cherries in, you'll notice that you put a cherry in every number that is in the 3 times table. 3, 6, 9, 12, 15 and 18. Now that we've looked at both the icing and the cherry, think about how you can use that information for the chocolate button. Where would you put the chocolate buttons? So hopefully you've had a go at the chocolate buttons. Let's have a look at the answer. So again, we put icing on every multiple of 2. We put a cherry on every multiple of 3. And because we are looking for every fourth biscuit, for a chocolate button, we would have gone 1, 2, 3, 4, yes. 1, 2, 3, 4, yes. 1, 2, 3, 4, yes, etc. And you'll notice the chocolate button has gone on every number that is in the 4 times table, every fourth biscuit. Now, I wonder if you can spot the answer now to the question. So the question was, how many other biscuits have no decorations? And did any of the biscuits get all 3 decorations? Well, we can see that number 1, 5, 7, 11, 13 and 17 and 19 all have nothing. They're all empty. I wonder why that is. I wonder if you could have a think about why that might be. Then if we look, how many had all? There's only 1 that had all of them, and that is 12. Have a think about why maybe 12 is the only biscuit that has all 3 decorations. So hopefully you've paused the video and had a think. Now let's go through the answer. Well, the answer to why this one is the only one that has all 3 is because it is in the 2, 3 and 4 times table. 2 times 6 is 12 and 3 times 4 is 12. and that means that it's on the second, third and fourth biscuit. Well, why is it the only one? Well, that is because it's the only biscuit from 0 to 20, the only number from 0 to 20 that is in both the 3, 4 and 2 times table. But I wonder if you could extend this further if you've been quite quick at this at home. Can you think about what number would be next? What biscuit would be next to have all 3? And what if you added in a 4th decoration that happened on every 5th biscuit? When would be the first one to have all 5 and then all 4, and how many can you think that would have all 4 decorations? You could choose anything. It could be sprinkles, it can be anything you like. So there is the answer to the problems visually, but have a think about how you could extend it further. Explain why these numbers have none, but also think about what would be the next number if you carried it on to have 3, or invent your 4th decoration for every 5th cake, and then think about which ones would have all 4 decorations. Good luck.